Welcome back, everyone. We're going to be solving LeetCode 133 clone graph. So we're given a reference of a node in a connected undirected graph. We want to return a deep copy or a clone of this graph. Each node in the graph will contain a value integer and a list node of its neighbors. So our test case format, they tell us each node's value is the same as the node's indexed, which is 1 indexed. For example, the first node with value equal to 1, the second node with value equal to 2, and so on. The graph is represented in the test case using an adjacency list. And then they just tell us what an adjacency list is, and they say the given node will always be the first node with value equal to 1, and we have to return the copy of the given node as a reference to the cloned graph. So, right, they give us this original graph, and we can't just say, okay, well, just return that original graph, right? We have to produce a copy of the graph. So, how, in this other example here, right, they also say the nodes were cloned, but the graph is messed up, right? So we have to have the correct ordering, right? They give us a graph of 1, 2, 4, and 3. So we have to output 1, 2, 4, and 3, not 1, 3, 4, and 2. So how are we going to solve this? Well, we can create a graph, essentially a dictionary, to hold all of the references to these nodes, right? And then the values are going to be new nodes, right? So when we run into this first node 1, we'll put it as a key inside of our graph, and then the value is going to be a brand new node of the value 1, which we will create, right? That'll give us this, the correct output answer, where we have a cloned copy of our original graph. So in order to do this, we are going to, or I'm going to run a breadth first search. You could just as well do a depth first. Again, I like breadth first better, so that's what I'm going to be doing. So we're going to implement our DQ from the collections library, import DQ. We will say, also there is a base case for this. If they don't give us a node, right, we can just return the empty node, essentially. So we can just say, if node is none, we can just return the node. Now we are going to initialize our graph to an empty dictionary, and we will also initialize our queue to be a DQ. And what is going to go on here? We are only given a single node, so we're obviously going to start with our node on our queue. Now we can just run our breadth first search. So we can say, while the length of our queue is not equal to 0, we're going to grab that node. We'll say, we'll call it current, and that is going to be with queue.popleft. Now, what do we have to do? The first thing we have to do is check to see if this current node is within our graph or not. And if this node is not in our graph, then we have to add it, and the value of the key that we add to our graph has to be a brand new node with the same value as our current node. So we'll say if the current node is not in our graph, the first thing we're going to do is we will add it. So we'll say graph of current will be equal to, right? This will add the current node as the key. But what is the value going to be, right? We have to create a new node. So they tell us, right, this is the node constructor. So we will say node, and what is the value? It is going to be current.val, right? So now we have our current node added into our graph, and the value of our current node is going to be a brand new node with the current node's value. Now the next thing we have to do is loop through all of the children of the current node. So we'll say, or neighbor in this case, we'll say for neighbor in current dot neighbors. What are we going to do? Again, we have to check and make sure, or to see if this neighbor is within our graph. So we'll say if neighbor not in our graph. All right, if it's not in our graph, what do we want to do? We want to do two things. We want to add it to our graph, right, just like we did here, and we also want to add the neighbor to our queue. So we'll say graph of neighbor will now be equal to a brand new node with the neighbor dot value, and we will add that neighbor to our queue. Now after this if block executes, we still have to say, because it's a neighbor of our current node. So if we scroll back up here to example 1, right, we can see 2 and 4 are neighbors of 1. Right, so within a normal adjacency list, we would have 1 as the key, and then we would have a list of 2 and 4 as the values. So that's what we have to build. We have to build that list of neighbors inside of this for loop. Once this if statement executes, then we can say graph of our current node dot neighbors. We want to append the graph neighbor, right? That new node that we just created. Graph of neighbor, and then at the end, right after we exit this while loop, our breadth first search has finished running. So what can we return? They tell us that we have to return a clone of the graph. So we don't want to return just the node, right? Because that'll give us this answer right here. It'll just return the same graph. We stored our graph in the values of our given graph dictionary. So we can just return the graph of the node that we are given. So let's run this. This should work. Perfect. We pass all 3 test cases, so we'll submit. Awesome, and it does run. So time and space complexity for this is going to be, time complexity is going to be O of n, and the space complexity is going to be the length of our graph plus the length of our queue. So we'll say queue.length plus our graph.length. All right, that'll do it for LeetCode 133.